or local maxima or local minima, then f dash of c must be 0. And I told you why this must be 0. You must see my previous lecture. Okay. What is the next? Next is LMVT, Lagrange mean value theorem. Mostly we will refer this guy as mean value theorem. Mean value theorem. You can also see this as Lagrange mean value theorem. What is the definition here? What is the statement? Let f from EB to R be such that, what are the two conditions? The first condition is f is continuous. F is continuous where? On closed interval a comma b. The second condition is f is differentiable on open interval a comma b. Then there is no third condition here. Then there exists C belongs to AB such that what is f dash of C? Or you can also say like this, f of b minus f of a. I prefer this one more nicer than that. F of b minus f of a, that is same as f dash of c into b minus a. Or you can also say that is this is what the statement of theorem is. Correct? How will you solve this? Okay, so this is the statement. Now I would like to prove. See, अभी क्या करने का? The technique is we have already proved the Rolle's theorem, correct? So let us try to use that theorem. Can I make my whole question in that form? Can I do that? That means I need to have a function which should satisfy all the three conditions. First and second condition is already satisfied. I just need to get one more condition, that is the third one. So you should decide what function should I choose. So let us have some guess. So I would like to define a new function such that what should I have? I should have g of a equal to g of b आना चाहिए, ठीक है? Okay, suppose I am taking g of x equal to say f of x, ठीक है? And if I put x equal to e, it will be f of e आएगा. But what I want, it should be same as that one, na? So let us do one thing. Let us just add this f of b minus f of a upon b minus a into x minus a. Let us check now. What is g of a here? What is g of a? Maybe I need to make. Let us do one more thing. इसको g नहीं लेते हैं. Let us make our life easy little bit. Let us say this is L of x बोलता हूँ मैं, and my g of x is this. Say g of f of x minus L of x. What is g of a? Check. This is L. What is g of a? It will be f of a minus L of a. That is f of a, और यहाँ पे क्या आएगा? 0 आएगा, correct? So that will give me 0, correct? So g of a is 0. What is g of b? It will be here. It will be f of b minus. here it is f of a plus यहाँ पे b minus a, this will get cancel, I am having f of a और ये भी cancel होगा, I'll be getting f of b. So f of b minus f of b, that is again giving me 0. Do you see? Can I say that this g of x satisfy all the condition of Rolle, satisfy all conditions of Rolle theorem? Let us check quickly whether it is continuous. Yes, it is continuous. Why? Yes, why? This is the L. Do not confuse. It satisfies since it is continuous. Why? It is just you use algebra of continuous function. It is product of two continuous. Actually, this is scalar. Actually, this is linear function. You can say it's a linear function, and this is just by algebra of two continuous function. You can see this g is continuous and it is differentiable again by algebra of differentiability, and you are having g of a is same as g of b. So by Rolle's theorem, what happened? There exists a point C which belongs to AB such that g dash of C must be 0. What is g dash of C? That means it will be f dash of C minus L dash of C. It must be 0. पहले L dash निकालो. What is L dash? This is 0. X minus a का derivative, and it will be this whole thing f of b minus f of a. So I'll be having what? F dash of C is equal to f of b minus f of a upon b minus a. That's it. Hence proved. So the trick was this function. To decide this function, this was the trick. Now you must be wondering, sir, मतलब फिर भी ये समझेगा कैसे कि यही function choose करने का? What should I do with this? Correct? So let us think about that. Graphically पहले देखते हैं what is meaning of this thing. Your function must be continuous, it should be differentiable, and there should exist point C such that something should happen. Okay, let us graphically see, and then we'll get to know कि क्या problem है, क्या issue आएगा. Say this is point A, this is point B. Here you are not given anything. क्या f of A and f of B पे कोई भी values ऐसा कुछ बोला नहीं गया है, ठीक है? So you can say something graph is something like this. Yeah, say this is point A and say this is point B. What do you see? f of A और f of B में कुछ relation दिख रहा है तुमको? You just know that they are different, that's it. You don't have any relation in between. And do you see that function is continuous in this interval a and b? Yes, it is continuous. Whether the function is differentiable in the interval? Yes, it is differentiable because there is no edge. So I am satisfying all the two conditions of mean value theorem, that is Lagrange mean value theorem. Correct? Now what is my claim? My claim is to prove there exists a C point EB such that f dash of C should be same as f of B minus f of A upon B minus A. Do you observe this is actually slope of 2 points? And what are the 2 points? A comma f of A and B comma f of B. This thing is actually slope of 2 points. So actually I am just taking a slope of these 2 points. So this is the point and I am taking the slope, and what I am saying, this slope is same as there will be a point जिसके tangent से same होएगा. F dash of C means what? Tangent of that, tangent of the function at point C. So this guy is saying slope between these 2 points is same as a point. And what do you see? Iske a parallel. See, two lines are parallel. They have the same slope. So I have to find a line which is parallel, and that line should be tangent. So where will that be? I think that will be here somewhere, which seems to be parallel to the above line. Correct? So this point C should be here. Do you observe? Do you see? This is what your mean value theorem is. Your function was continuous from A to B, it was differentiable from A to B, and you are having this point A and this point B. I observe something. I have to prove f dash of C is equal to this. Look at this thing. This is actually slope of 2 points. What are the 2 points? This is A comma f of A and B comma f of B. These are the 2 points I am having. So अपने को करना क्या है actually? We just have to find a point C such that the slope of tangent of that point C is same as this slope. So I got this point. Correct? So how can you find this L of x? What I am taking this L of x, look at this L of x. It is actually, if you observe properly, it is actually something like slope point form. This is my slope and slope point form. When your function is something like this, L of x minus f of a, that is equal to f of b minus f of a. This is a constant for me, you don't worry about it. And this is x minus a. Do you remember what is slope point form? Suppose I am having this as a slope, and suppose I am having a point. I know the point a comma f of a. So can I find a straight line? Yes, definitely I can find. And this is the straight line. This L of x is a straight line. Do you understand what I am doing here? Actually, I am finding a straight line passing through these 2 points. स्लोप पहले से मिला था मुझे, जस्ट मुझे स्ट्रेट लाइन का इक्वेशन निकालना था. तो दैट इज व्हाट आई डिड. L of x equal to f of a plus f of b. Now I look at this thing. What is L of a here? What is L of a? This is same as f of a. And what is L of b? This is same as f of b. Correct? That means what मैंने क्या किया, ये जो straight line form कर लिया, which is same as f of a and f of b. That is initial point is f of a. See, ये जो straight line है ना, from here to here, I am finding the equation of this straight line. I am telling this as L of x. I am saying this straight line as L of x. Correct? So from there I got an idea like this. This will have this condition. If you have g of x is f of x minus L of x, if I take, then what is g of a? It is 0. What is g of b? It is 0. Because what is g of a? What is L of a? That is same as f of a. So g of a क्या आएगा? f of a minus f of a. And g of b will be f of b minus what is L of b? That is f of b. So it is again 0. So this thing is satisfying all the conditions. Correct? Yeah. An application to this, hence this completes the proof. An application to this is this one, say applications of mean value theorem MVT. The first application you can say this one. Let J be an interval and f from J to R be differentiable with f dash of x is 0 for all x belongs to J, then the function is constant, then f is constant. See, this is very nice example if you want to learn mathematics properly. See, mostly 11th 12th में the big mistake what people used to do is they always say कि अगर derivative 0 है then function constant. If your derivative is 0 then function is constant, which is a wrong statement. This is definitely not a right statement, this is wrong statement. I'll give you an example. Look at this function. Suppose this is point 1, this is point 2, and I'm having from 0, say 0, 1, say 2, and say 3. Suppose let me define the function. Suppose I'm taking f of x equal to say 1 when your x is lying between 0 and 1. Okay, and it is 2 when your x is lying between, say यहाँ पे मैं 1 को fix कर देता हूँ, यहाँ से 2 को fix कर देता हूँ, and this is my function. What do you see the derivative of function? What do you see the derivative? What do you know about f dash of x? Do you see it is 0? Because if you see in this interval it is 0, in this interval it is 0, constant. But what do you know about function? Do you see this is not a constant function? Constant मतलब क्या होता है? हर एक वैल्यू के लिए it should be a unique value. f of x must be some constant k for all x. But in this interval I'm having this constant, in this interval I'm having this constant. So why this so? What is the problem here? What is the problem here? What do you think the issue is here? Actually, this function must be continuous. If you are talking about differentiable, then it must be continuous. Now, look at the first statement. It should be differential. J must be an interval. J must be an interval and f must be differentiable. Differentiable है मतलब क्या? It should be continuous also. Correct? If your function is differentiable, then it should be continuous also. अगर मैं तुमको बोला हाँ भाई ये फंक्शन डिफरेंशिएबल है, so it must be continuous also. But is it continuous function? No, it is not continuous function. So जो मैंने f dash of x का लिए 0 बोला, it is 0 for this and for this. That means f dash of x is 0 here, but your function is not at all continuous here. Derivative of f dash of x, you cannot say anything. It looks key derivative is 0 and something like that. So this statement is completely wrong. If somebody says that if f dash of x is 0 then your function is constant, this is definitely wrong. Let me tell you one more example if you want. Look at this function. Suppose you are having u as an interval, say -1 to 0, union 0 to 1. Okay, and same again, say f of x equal to -1 and f of x equal to 1 when your x is in this interval, say -1 to 0, when your x is in this interval 0 to 1. What do you see? What do you see? F dash of x is 0, but whether your function is constant, but f of x is not constant. Do you see that? Derivative 0 है, so you cannot say that function is constant. In the previous example also I gave the same thing. Derivative 0, but f of x is not constant. So if you are going to help your 12th standard, 11th standard student, if they say कि derivative 0 then function constant, then tell them this is true only if your function is differential and this is given. That j must be an interval. This j must be an interval. Look at this here, it is not an interval. Interval means what? There should not be a break. They are not at point 1, they are not same. There is a break in between. Here also, do you see? 0 is not included here. I should remove here from 1 को भी remove करते हैं ऐसा. Yeah. So do you see 0 is not included here? मतलब 0 पे कुछ वैल्यू ही नहीं है. There is a break. It is something like step. So this guy is not an interval here. This was the issue. That's why this does not satisfy the condition. Derivative is 0, but f of x is not constant. This should be an interval. Interval means what? In particular, you can say it is a connected set. It should be a connected. What do you mean by connected? There should not be any break in the interval. Okay, 1 to 2. 2 I'm no. I think I wrote here wrong. It should be 1 to 2. No, it should be 1 to 2, and here it should be 2 to 3 as per the diagram. So 1 to 2 I am having, and I am having 2 to 3. It is not interval. It is actually union of two intervals. So it is not connected. Later on in FyBsc you will learn this thing. What do you mean by connected set? So the main motto is this thing you need to remember. Your g must be an interval, function must be differentiable, and derivative 0, then f must be constant. If somebody says derivative is 0 and function is constant, this is definitely wrong. You should give them this example. Give them this interval, and definitely it should be disconnected. It should be not connected. क्योंकि connected किया तो you'll do the same thing here also. जैसे मैंने बताया था, differentiable है, but it is not connected. It is not an interval. I hope you understand this. This was the important thing. Proof for this is for you. Try to use this mean value theorem. You'll get that for every z you are getting derivative 0. That is given. Just put कर दो function में. You'll be getting f of x is same as f of b is same as f of a. That means your function must be constant, and it is true for all. I'll give this as proof for this is homework. Just to focus on this was the main intention to do this thing. Mostly people used to do this mistake that if they say derivative 0, function is constant. Many of the junior college teachers also, classes teachers also, they used to refer this. If derivative 0, then function is constant. But this is true only if you are having your j, your interval must be, it should be an interval. It should not be a break something. It should not be union of two open interval. It should be connected in particular, you can say. It should be connected. And similarly, एक और application देखो तो people used to say ना derivative positive तो function is increasing. Here also you need to understand कि that is only when you are having your interval. Let G be an interval. So the word interval is very important here. And f from G to R be differentiable with f dash of x greater than 0 for all x belongs to J, then f is increasing. Okay, and again, what people used to do mistake here, they say if f dash of x is greater than 0, they directly say that implies f is increasing, which is wrong. Which is wrong. You should mention what is your interval, whether j क्या है, interval है कि नहीं, whether it is connected or not. Then only you can say whether it is increasing or not. People from the junior college, उनको कुछ फर्क नहीं पड़ता about this mathematics and this thing. They used to take अगर f dash of x greater than 0 है, then function is increasing. This is not true. And I want you to find a counter example. Find an example where that j is not an interval and your function is not increasing, you can say, and derivative is greater than 0. You can have so many examples if you break the function in between. You just try to draw a graph. यहाँ से suppose ये बोल दिया and break this point, and suppose यहाँ पे ये बोल दिया ऐसा कुछ. Derivative positive चाहिए ना, greater than 0 चाहिए ना. So again I'll be just making 60 degree angle. तो यहाँ पे मैंने tan 30 बोल दिया, यहाँ पे tan 60 बोल दिया, तो आई एम गेटिंग दोनों का डेरिवेटिव मिल गया मुझे दोनों जगह पे, एंड आई कैन सी दैट दिस फंक्शन दिस इंटरवल ये यहाँ से यहाँ तक कवर होता है एंड दिस इज टेकिंग यहाँ से यहाँ तक. दिस इज नॉट एन इंटरवल. I cannot, and do you see that function is definitely not a constant function or not an increasing function. You see, यहाँ से यहाँ तक तो increase हुआ, but it should follow यहाँ से भी increase होना चाहिए ना, but यहाँ पे decrease हुआ. It decrease here, then it goes up. So this is not an increasing function. And similarly for decreasing, your focus should be on this. So whenever you see somewhere कि derivative positive बोल रहा है function increasing, so you should stop there only and give them some example. What is the issue? Why this thing is not true? Why this is interval is required? Why the word interval is required here? Is that okay? One exercise I'd like to give you, maybe homework, or I'll say fuzzy problem. Think about this. Who is bigger, e raised to pi or pi raised to e? And if somebody got the answer, you can send it to me directly. E raised to pi is bigger or pi raised to e bigger? Who is bigger? Okay. Next lecture will be based on this thing only. Again, I want somebody to answer me. Who is bigger? Who is greater? Either e raised to pi is greater than pi raised to e, or pi raised to e is greater than e raised to pi. Bigger, I am not talking about size. Huh? It is, maybe I'll just reframe it. People are, so I can say like this: which is greater? Greater out of them, e raised to pi or pi raised to e? That is the question. Okay. Do not Google. This is main. Mostly, कोई भी question देखा, people used to go directly on the internet. So don't use internet. Think about e raised to pi बड़ा रहेगा कि pi raised to e. ठीक है? Okay, I stop now. Thank you so much.